This video, I'm going to introduce you to proximity analysis in a GIS. And so we'll look at how ArcGIS, in this case, has created different buffers based on different inputs. And so our inputs can be a point, line, or polygon, but the output is always a polygon feature. So what I mean by that is here is the brown fields, and this is a point layer, so we see the orange dots here. And what I've done is I created a 1 mile buffer around those orange dots. So we can see kind of the benefits of a proximity analysis. So in environmental science, you often see these types of analysis related to kind of the protected zones around lakes and streams and various environmental phenomena, kind of the zones of environmental regulation. Around highways, urban planners will often kind of do these buffering analysis when they're looking at noise pollution along an interstate highway. And so we can vary the polygon size, and so here in this case I've made the brown field buffer a 5 mile buffer. So this is just showcasing in this example how I can do a buffer, doing a buffer using, in this case, a point as the input. Now let's use a line as the input. So what we'll do is we'll go ahead and put in the interstates, and then I'll do a 1 mile buffer around the interstate, and then a 5 mile buffer around it. So once again, the interstate is a line feature. However, the buffers that have been created are a polygon feature. And so here's an example of then how you can do a buffer for a line. Finally, I'll do a buffer for a polygon. In this case, we have the Indianapolis incorporated area that is shown here in orange. What I'm going to do is then create a 1 mile buffer around the corporate limits, and then a 5 mile buffer around it. So essentially what I've done is I've taken a input, in that case being a point, a line, or a polygon. In all of these cases, I then created a buffer of varying sizes that is a polygon. Now I'm going to introduce you to another type of proximity analysis, and that's called a Thiessen Polygon. So a Thiessen Polygon, the idea here is it typically has point data as its input, but the output is always a polygon. Mathematically, it's defined as the perpendicular bisectors of the lines between all points. So what I did here is I did a GIS, and so I asked it, based on these input features, these blue dots, which are the locations of hospitals in Indiana, I asked the GIS to create some Thiessen polygons around each of these individual points. And so here's the result of that. So if I kind of go zoom in, we see these polygons that have been created around each of these individual blue dots. So the idea here is along this line is exactly halfway between this hospital and that hospital. Similarly, this particular line here is exactly halfway between this hospital and that hospital. So then, at this point where we have 3 lines coming together, this is a place in which it's equidistant to this hospital, that hospital, and that hospital. And so when we think about hospitals, proximity plays a key role. If you have a stroke, if you have a heart attack, of course, the distance from a hospital that can take care of that condition is quite important. And so we kind of can zoom out and start to do some analyses as far as, okay, where in Indiana do people have a longer distance to travel to get to a hospital? That's going to be those up here with these bigger polygons. These are going to be more the rural areas of Indiana where it's quite remote and hospitals and people are spread out farther. But we go and we zoom into the metropolitan Indianapolis area, you can see the polygons that are much smaller. So this is a particular example of a proximity analysis, creating these polygons around these individual point features.